This tutorial describes how you can access the CofC HPC cluster using either a command line interface or a graphical interface, and the emphasis would be on using remote desktop clients for to get access to a fully graphical Linux environment. So if you kind of take a step back and think about how you interact and work on the cluster, you're usually somewhere remote, either on campus or off campus, and the cluster is physically in a data center that's far away from you. So you would need to connect to it over a network using SSH protocol. And most people use terminals to get basically access to a command line interface connection to the cluster, whereas if some people, depending on their workload, prefer to connect to the cluster using a remote desktop client. And I'll briefly describe what the process involved is in each case. So if you're connecting using a terminal for command line interface, you need to have an SSH client on your local computer. So if you're a Windows user, you can use PowerShell, Mobax, term party. If you're a Mac user, there's iTerm and terminal. And even though these are very much intended for just kind of text-based command line interaction with the cluster, you can actually look at some graphics using X11 forwarding. But the trick is that you need to have a X server running on your local computer, both on Windows on the Mac. Unfortunately, if this is not really a very good way to kind of look at graphics or interact with graphics, because it really depends very much on the quality of your network and for the most part, even if your network is very good, exporting all that graphics over a network usually is going to be very choppy and the quality is not going to be very good. So for anything that's graphics heavy, you are better off using a remote desktop client to get a fully graphical environment on your local machine. So this remote desktop clients allow you to get a complete Linux desktop environment. There's different desktop environments. If you've used a Linux machine before, GNOME, XFCE, KDE are kind of the common ones. We encourage people to use XFCE since it's a lightweight desktop environment. And the remote desktop client that we use is called Syndio ThinLink. We have a Syndio ThinLink server running on the cluster. So on your local computer, you would need to install a Syndio ThinLink client and then basically connect to the cluster and get that nice, clean desktop or graphical desktop environment. And as always, if you're off campus, you would need to first set up a VPN connection before you can connect to the cluster using either the command line interface or the remote desktop environment. Okay, so what this demo will do is we'll take a Mathematica notebook that doesn't have a lot of graphical output and run it from a terminal, and then we'll run another one which has a lot of graphics and animation using a remote desktop environment. Okay, let's start by running the Mathematica notebook in a terminal. So I'm gonna exit out of here, and I'll use Windows PowerShell. Just do a search for power, should be able to come up first. So what I'll do is SSH as test user to the cluster. I have SSH key set up, but if you don't, you can just enter your password. Okay, so here's some of the directories that I have under there. Under Mathematica examples, I have a few examples we could run. So usually to provision software on the cluster, we use something called module. So module Spider Mathematica looks for a software module called Mathematica, and it's telling us there's one under Mathematica 12.0. So load up that one. Okay. So there's Mathematica. So if I want to run it using a text-based option, I'll tell it math run, and the example will run is going to tell us the number of prime numbers between basically 0 and I think 5,000 or 2,000. So here it's running using 8 cores. Actually, the number of Mersenne prime numbers slightly different from your regular prime numbers. And as you can see, what we're looking for is just a set of numbers. So a plain kind of text-based terminal works fine. So this is what the notebook looks like. So this is kind of perfectly good way of doing things. If I wanted to run this using a full Mathematica GUI, it would not work very well. In fact, if I try to run Mathematica here, it says you can't open it because I don't have an X server running on this on the my local Windows machine. So this is a good time to try and look at how we could do basically the same thing that we did in a terminal in a basically in a remote desktop environment. We have some documentation on setting up and running a remote desktop client on our website. So we can go to hpc.cofc.edu, and on the left column there's a link called Access Your Account. Under there there's a description of how you can use a command line terminal or use a remote desktop to connect to the cluster. So pretty much everything I'll be describing from here on out is summarized on this page. So the first thing you would need to do is download and install a Syndio ThinLink client on your local computer. So I'm going to go to the Syndio ThinLink page, go to download. I have Windows 10 machine, so install the Windows 10 client, and download install is fairly straightforward, so I'm not going to go through it with you, but I already have ThinLink client installed on this computer, so I'm going to open it up. So for the server name, you need to provide the hpc.cofc.edu, provide your username and your password. See if I remember mine. And some of the things that are described on the website are different options you probably want to enable or disable. So none of these local resources will need like access to sound or printers or different ports. So you probably want to disable all of them. For screen size, you probably want to set the screen size of your remote desktop to something slightly smaller than whatever the size of your current screen is. So in my case, I have a big screen, so I'm just going to choose a 1280 by 1024. And also you want to disable full screen mode, because that will occupy your whole screen and then it may be hard to escape out of that. So setting the right resolution and disabling full screen mode are probably advisable. For optimization, you don't really need to mess around with it all that much, but if you're somewhere far away from campus and the quality of your network connection is not very good, you may want to enable SSH compression to kind of minimize the traffic. And SSH ports, the default. I'm going to authenticate using my password, but if you have SSH public key, you can choose that and tell it to point it to where your SSH public key is stored. So these are some of the options involved in connecting with the link remote desktop client. So with all that information here, I'm going to go ahead and connect. And there we go, it has given me my remote desktop client connection. And this is just a full-featured XFCE desktop environment. Let's see. So if I want to do what we did in using a Windows PowerShell in this remote desktop environment, I can just right-click, open a terminal, and go to Mathematica examples. As always, I'm going to first load up Mathematica. Okay, so what we did before was basically Mathematica run this parallel Mathematica example, and it just ran very cleanly. So if I wanted to do this using Mathematica GUI, I can do Mathematica parallel file name, and it opens up the file in a GUI like this. It's just simple 4 lines that tell it to use 8 cores to get all the Mersenne prime numbers less than 2000. So if I want to run it, I'll go to evaluate and evaluate the whole notebook. And there it is. We get pretty much the same output using the GUI version versus the command line version. So this is not really a great example where using a remote desktop client would be very useful. So I'll show you next an example where the remote desktop environment does actually shine. And let's see, that one would be, for example, this notebook here that shows all the capabilities of Mathematica, whether it's just symbolic text-based calculations or kind of graphics and simulations. So here are some examples of what Mathematica can do. Something as simple as just simple kind of algebraic numerical calculations like these. Okay, it's taking a little longer than it should. Okay. So these take in a text input and give us a text output. So this is not really a good example for using a graphical environment. Same thing with this algebraic calculations. Let's see. Yeah, these are all text-based. So let's scroll down to parts where we actually do some graphics. So here we're trying to plot this function. Clearly we need a graphical interface to be able to see the graphs. There it is. If we want to generate a 3D plot like this, it's surely very nice to have a graphical environment where we can see these. And these are basically pieces that we can move around and interact with. And let's see, here's another cool graphic in 3D. if you have different animations, for example, this one here. Here's a nice graph that you can actually see and interact with. So these are all kind of different capabilities that definitely require you to have a graphical interface. And here's a one-dimensional random walk, two-dimensional random walk. So very cool examples. So hopefully these two examples show you the value of using a remote desktop environment for things that have graphical, that are kind of heavy on graphics, and where it makes more sense to use just a command line terminal, which is obviously much easier and cleaner. So one of the things that we want to emphasize is when you're done with your kind of calculation, running your notebook, you always want to make sure that you have closed all the applications and logged out. And the reason for this is that we have a limited number of Syndio ThinLink licenses. So if you occupy one, other people can't use it. So as much as possible, try to be mindful of that and log out whenever you're done. So we have closed your remote desktop session. Just to close off, there's a few things probably worth highlighting. And one is, as I just mentioned, please make sure that you have logged out of your Syndio ThinLink remote desktop session when you're finished because of the limited number of licenses. Two is what we've done so far is just logged into the head node or the login node to do these simple calculations. But if you have anything that's heavy duty that takes a lot of CPU memory time, what you want to do is request resources for appropriate resources using Slurm, and then Slurm would tell you you can use this node to run your calculation, and then you can log into those nodes to do the actual heavy duty calculation, and we'll have a tutorial on that shortly. Another thing we probably want to note is in this tutorial I've highlighted the fact that you can interact and work on the cluster using text-based SSH terminal or a remote desktop environment. Another way you can interact with the cluster is using kind of web interfaces. So there is very specific web interfaces where you don't even have to, you essentially log in through a web interface and run your calculations. You may have to do some of the setup using a terminal, but all the interactions that you'll have with the cluster for the most part would be using a web interface, and that's one way that a lot of people convenient, and we'll have tutorials on that, especially on ways you can use Jupyter notebooks to run kind of Python or MATLAB scripts, or if you're a chemist, how to use WebMO to do calculations. There's some things called gateways that allow you to do a lot of domain-specific calculations, something called Open on Demand. So these are all different ways that you can do calculations on the cluster using a web interface. So if you have any questions about this, you can always email us at hpc@cofc.edu or submit a ticket using the IT's Team Dynamics website. All right, thank you.